Okay, in 2.6, we're going to look at transformations of functions. I will look at vertical and horizontal shifts, translations, things that we've already done before in Algebra 2 and pre-calculus a little bit. We'll look at reflections over the x-axis, vertical, and y-axis, horizontal. Then we're going to look at vertical stretches and shrinks. I'm actually going to talk about horizontal stretch and shrink just briefly, but you will not be tested on it. But I'll just show you the difference so that you can get vertical and vertical stretch and shrink narrow or based, so you can get vertical shrinking and stretching that understood. Okay, let's talk about 2.6 transformations of functions and the learning target. Understand and recognize the effect of a number and the sign changes to the original form of the function. Let's talk about a vertical shift. This is something that you guys already know. We've shifted quadratics, we've shifted a bunch of different graphs before. But suppose that c is greater than 0. To graph y equals f of x plus c, a plus c shifts the graph up c units. But a graph of y equals f of x minus c shifts the graph downward c units. So whatever the graph of f of x is, plus c would move it up that many units, and minus c would move it down that many units. Now let me clear that up. If that value is outside the parentheses, it's not inside the parentheses with the x. If it's outside the parentheses, it is a vertical shift. Vertical shift. Let's look at the horizontal shift. Now you can see that the shift, the value of c is on the inside of the parenthesis. If it's on the inside of the parenthesis, that represents a horizontal shift as opposed to the vertical shift. But there's something that's unique about this. It's actually opposite. So if y equals f of x minus c, instead of it being shifted to the left like we think because minus, it's actually shifted to the right. All right, and that has to do with the value of x that you plug in and what number you'd get to make this 0. To graph y equals f of x plus c, that's plus c, it would shift the graph left c units. Again, it's plus c, but it's opposite to the left. Now let's talk about reflecting graphs. If you take the graph of y equals negative f of x, this is a reflection of the graph over the x-axis. Same thing, if you have y equals f of negative x, this is a reflection over the y-axis. Now let me just clear this up. This is basically saying negative f of x. F of x is like your entire function of y. The way I used to memorize this is f of x is my entire function y. If I make it opposite, I reflect over the x-axis, the opposite, the other axis. If I make the x negative, I actually flip over the other axis, the y-axis. That's the way I used to remember it. Otherwise, you can just look at it like this. Let's just talk about this one first. I'm reflecting over the y-axis like this diagram is doing here. Right? I'm making the x opposite. So if I had an x value here, I'd check the opposite of that value and I'd be over here. So it reflects over the y-axis. Same thing for this one. This is like saying, hey, let's make the y value opposite. So if I have this y value here, I'm going to make it opposite. It goes down to here, and therefore it flips over the x-axis. Now let's talk about the vertical stretch and shrink. If c is greater than 1, notice that c is on the outside of f of x. It's multiplied to the entire function. Like for quadratics, it would have been your a value outside the parentheses for the quadratic function. The graph of y equals f of x is stretched vertically by a scale factor of c. So if c were 2, your whole graph would stretch by a scale factor of 2. But if that c value is between 0 and 1, keep in mind we're not talking about negatives. Negatives will be a reflection. But if c were between 0 and 1, some kind of decimal or fraction, then it is now a vertical shrinking by a scale factor of c. So if it was like 1/2, your entire graph would shrink by a factor of 1/2. Notice that the factor of c is multiplied to the outside of the function. Here's what you're not tested on. Here's a horizontal shift. The c value is actually multiplied directly to the x value on the inside of the parenthesis. And if c is greater than 1, it'd be 1 over c. That's actually a shrink. If c is between 0 and 1, that would be 1 over c as well. That would actually be a stretch. You don't have to worry about this page. I just want to make sure you're clear of what a vertical stretch and shrink looks like. The c value will be multiplied to the outside of the function, and it affects the entire function. Okay, let's take a look. Example 1 here. What I like to look at first is what does the new function do? We're going to call this blue function f of x, and now we're going to take a look at what the black function does to your graph. Let's write that down. We have y equals f of x plus 3. This plus 3, I'm going to write down what it does. It moves your graph to the left 3. So now if I take this graph, watch me, I actually can move this. Any point, I can move everything to the left. 1, 2, 3. I'll make this graph black for you so you know it's matching the black graph up there. And there you go. That is the graph of A. Label it. For B, -4, it's on the outside of the parenthesis. This is a shift down, vertical shift down 4. Okay, so I'll take the blue one and move it down 4. 1, 2, 3, 4. There's the graph. I'll make it red for you. And that is the graph of B. So you get a horizontal shift for the black one and a vertical shift down for the red one. Example 2. The red one, a negative f of x, all right, that's some type of reflection. All right, remember what I said, I like to think of it as the opposite. So it's reflected over which axis? It's a reflection over, the negative is to the entire function of y, so I say it's a reflection over the x-axis, over the x. I'll do the black one since I have it right here. The x is negative, so that's a reflection over the y. Okay, let's do it then. So if I reflect over the x-axis, that's my horizontal axis, reflect over the x-axis, I can do this, I believe. Let me just pull one out of here. Use this one. I'm going to flip it over. So it reflects down, I guess you could say. Reflect over the x-axis. I think I can do it. There we go. Flip up and down. That actually should make sense. That's reflected over the x-axis, and it flips just like that. This is your red one. That is A. Flex over the y-axis. That is going to be a reflection over the y-axis, and so that will be a shift, a flip left and right. So let me just take a graph out of here, flip it left and right. It is going to look just like this. That one is the black one. There you go. That is the graph of B right there. Now, keep in mind, here's how you can flip over the y-axis. I'm just going to show you a couple points. I can take this point, it should flip over the y-axis all the way to this point. Same distance from the y-axis. Same thing with this one, from there to there. That's just a way you can also reflect if you have numerous points. Okay, so let's understand the difference between the horizontal, vertical stretch shrink. So again, here it is. I did want to talk about it. We talked about what the difference is between a horizontal and a vertical stretch and shrink. We're only going to focus on the vertical. And remember, take a look at this example. We have y equals 2 times x. We should know that that is a vertical stretch or shrink. We're not even doing horizontal, so I can actually cross that off. All right. Do you know that this one should be a vertical stretch or shrink because the value is multiplied to the entire function. All right. So here's the points of this graph: -4, 4, -2, 0, 1, 3, and 3, 2 here in red. It's all sitting there. So if I'm going to multiply the entire function by 2, if I multiply the entire function by 2, it is going to change our y values. All right, so take 2 and multiply it to your y values. I have 4 here. All right, 4 times 2 would give me 8. All right, again, 2, this 2 value, again, is multiplied to the entire function. It's multiplied by the y value here, here, and here, and I should get 0. 2 times 3 gives me 6. It's multiplied right there. And 2 times 2 will give me 4. All right, let's do the 1/2. Then we'll graph it. 1/2. So half of all my y values. 2, half of 0 is still 0. Half of 3 is 1.5. Don't be afraid of decimals. And half of 2 is 1. All right, so what does this graph look like? All right, if you plotted the points, you would get this graph. I think I have it right there. That's not it. There it is. All right, there's what it looks like. If you were to graph all of it. All right, the green one is the stretch by 2, and the black one is the shrink by 1/2. Okay, moving on. So now it says describe the changes to the graph of the function. I'm going to do these in the next video, and then we'll go from there.